Good afternoon, my YouTube viewers. In this video, we're going to be discussing some more experimental design. And basically, in this particular practice question, we're going to optimize farming practices by evaluating variables such as soil conditions, irrigation levels, and crop treatment. So we're going to write a program in Python to answer this question. And before we write the program in Python, what we're going to have to do is we're going to have to import some libraries. We're going to have to import quite a few libraries to be exact. So the first library that we're going to import is NumPy SNP, and that's a numeric library that creates NumPy arrays. The second library that we're going to import is Pandas SPD, and that's a data processing library with that also creates data frames and series. The third thing we're going to import is matplotlib.pyplot as PLT. That's a visualization libraries. And from itertools, we're going to import product. And itertools is a library that helps with iterations. And from scipy.stats, we're going to import F1way. So scipy is Python scientific library, and stats is a statistical module within scipy, and F1way is one of the hypothesis tests in the statistical module. So what we're going to do after we import the libraries, we're going to set our seed. And what happens when you set your seed is you set whenever you run the computer, all the variables are set up with the same values. And that's why you want to set the seed up so the computer program will run the same every time you execute it. So you set your seed by typing np.random.seed and anything you want, any number you want within the brackets. And now we're going to define the factors and their levels. So soil types is a list of loamy, sandy, and clay. Irrigation levels is a list of low, medium, and high. And crop treatments is a list of fertilizer A and fertilizer B. So we're going to generate all combinations of factors. It's a full factorial design. So combinations equals list, brackets, product, brackets, soil types, comma, irrigation levels, comma, crop treatments. So now we're going to simulate crop yield quintiles per hectare for each combination, and we're going to add a variability for each factor and interaction. So data is going to be a blank list, an empty list, and for soil irrigation treatment in combinations, base yield equals 50. Soil effect is a dictionary that has loamy equals 10, comma, sandy equals -5, comma, clay equals 0. Irrigation effect is also a dictionary. It has low is -10, medium is 5, and high is 50. And treatment effect is also a dictionary that has fertilizer A as 5 and fertilizer B as 10. Variability equals np.random.normal 0, 5. So basically what you're going to do is you're going to create a normal distribution that's going to have a mean of 0 and a standard deviation of 5. Total yield equals base yield plus soil effect plus irrigation effect plus treatment effect plus variability. And then the data.append brackets soil, comma, irrigation, comma, treatment, comma, total yield. And then so what happens is every time the for loop iterates, it's going to append all of that data. And so the for loop is going to iterate it doesn't really say how many times it's going to iterate, but it should say how many times it's going to iterate. It said base yield equals 50. So let me just look and see. It doesn't say how many times it will iterate. That's the problem. It gives you, because you have a for loop and you're supposed to, for soil irrigation and treatment in combinations, and it gives you soil types, irrigation levels, and crop types. So it will only iterate the number of times, like maybe it'll only iterate like 3 times for these soil irrigation treatment and combinations. And so maybe it will only iterate 3 times to cover the soil types, the irrigation levels, and the crop types. But we're going to create a data frame using pandas. So df equals pd.dataframe brackets data, comma, columns is a list of soil, comma, irrigation, comma, treatment, comma, yield. So that means you're going to have 4 columns of data. The 0 column is soil, the 1 column is irrigation, the 2 column is treatment, and the 3 column is yield. So we're going to summarize these statistics. So summary equals df.groupby brackets soil, comma, irrigation, comma, treatment, comma, treatment, and then that's the end of that list. And then you have a square brackets yield.mean.unstack. And then you print a summary of these statistics. And so basically what we're going to do is we're going to come down to the end of this cell. So the treatment is fertilizer A and fertilizer B, and the soil irrigation is clay, loamy, and sandy, and it gives you the statistics for the fertilizer A and the fertilizer B, and the soil irrigation. Clay is high, low, medium. Loamy is high, low, medium. Sandy is high, low, medium. And then so that's the statistics that are produced when we summarize the data with the group by. So now what we're going to do is we're going to perform an ANOVA. And an ANOVA is an analysis of variance. And you use an ANOVA when you want to check the means of 3 or more samples of data. So ANOVA results equals F underscore one way brackets DF soil is equal to loamy square brackets yield, comma, DF soil is equal to sandy, square brackets yield, comma, DF soil is equal to clay, square brackets yield. And then what we do is we print the ANOVA results, and then we print the F statistic and the p-value. And your p-value is a probability. So the ANOVA results, so your F statistic is 3.785 and your p-value is 0.047. So if the p-value is less than 0.05, that means the null hypothesis is rejected because there is a significant difference in the values. So since the null hypothesis is rejected, since the p-value is less than 0.05, the null hypothesis will be rejected in favor of the alternate hypothesis. And the alternate hypothesis says that there is a significant difference between the values. But in this particular exercise, they're not checking the p-values, but I was just telling you what the p-values would be if they checked the p-values. And so now what we're going to do is we're going to visualize the bar plots for crop yield by different factors. So PLT.figure brackets fig size equals 6, 4. We're going to plot the crop yields for soil types. PLT.subplot brackets 1, 2, 1. Soil means equals df.group by brackets soil square brackets yield dot mean. Soil means dot plot brackets kind equals bar, so it's a bar chart, comma color equals blue, orange, green, comma alpha equals 0.7. The title is average yield by soil type. The X label is soil type. The Y label is yield quintiles hectare. And the grid is axis equals Y, comma line style equals dashes, comma alpha equals 0.7. So now we're going to plot crop yields for irrigation levels. So PLT.subplot brackets 1, 2, 2. Irrigation means equals df.group by brackets irrigation square brackets yield dot mean. Irrigation means dot plot brackets kind equals bar, comma color equals blue, orange, green, comma alpha equals 0.7. The title is average yield by irrigation level. The X label is irrigation level. The Y label is yield quintiles per hectare. And the grid is axis equals Y, comma line style equals dash, comma alpha equals 0.7. So PLT.type layout, and we're going to show the plots. So you can see we've shown the plots here where you have average yield by soil type and average yield by irrigation level. So the loamy soil type gives you the highest yield, and the high irrigation level gives you the highest yield. So your best bet is to use loamy soil with a high irrigation level. That's your best bet. And always try a high irrigation level. And that concludes this video. The next video, we're going to be covering some more experimental design, and I hope you decide to watch it.